Arushi, welcome back to Gift, my friend. How are you?
I'm doing great.
You're great. Fantastic. I'm going to make an assumption. Are you on summer vacation from school?
Yeah, I just started.
You just started. And what grade did you just finish?
So I just finished grade 6, so I'm going to grade 7 in September.
Very exciting. And how are you going to be spending your summer?
Well, I'm going to be, of course, going a lot outdoor because I want to stay out of the computer and like do some camps and maybe even work on some projects.
Fantastic. Fantastic. I'm not that surprised to hear that you have such big productive plans on your vacation time. And we're really excited, Arushi, to hear about your Hot Pop robot today. Is that right?
Hot Pop Robot is my organization name.
Oh, pardon me, pardon me. So what are you going to be telling us about today, Arushi? Why don't you take the mic and feel free to share your screen?
Sure, yeah. Okay, I'll just share my screen now. So can you see my PowerPoint?
Yes, sir, we can.
Okay, great. Yeah. So today I'll be talking about the 2021 Planetary Defense Conference that happened and an interesting asteroid impact scenario that they had. So a quick background on me. My name is Arushi, and as I said before, I'm going into grade 7 next year, so I'm in grade 6 right now. So first of all, what is the Planetary Defense Conference? So basically, this is a conference that happens every 2 years and happens for 5 days. This is where people all around the world meet up to discuss about asteroids and their threat to the Earth. And there's so many interesting presentations that happen, poster presentations and actual presentations where people talk about, for example, their experience with asteroids or what they learned or some experiments that they did. And actually, I also presented at the Planetary Defense Conference this year. And in this conference, I presented about my journey imaging an asteroid called Apophis and about the telescopes I used, what techniques I used to find the asteroid, and what I did afterwards. So yeah, and in this conference, they also have something extra. They also have an asteroid impact simulation. And what this is basically they create an imaginary asteroid each time. So that asteroid doesn't actually exist. And in the beginning of the conference, they give us some information about this asteroid, like its magnitude and so its brightness and so on. And every day of the conference, they give more information about this asteroid based on new observations that they have taken. And using the new information that they were able to get, they were able to find lots of information about the impact of this asteroid, like if the asteroid is going to impact the Earth at all, and what's the percentage that it will impact, and how much damage will it do to the Earth. And at the end, they also give a simulation where the asteroid is going to impact the Earth, and you have to find means to deflect it using a kinetic impact. So I'm going to be basically running through all 5 days and each new information that they give. So first, the baseline information. So this asteroid for 2021 PDC was actually called 2021 PDC. And just a quick reminder that this is actually not a real asteroid, and this is a fictional asteroid that they created. And when they observed this asteroid on 19 April 2021, they saw that its magnitude was 21.5. And they detected that this asteroid had a risk of impacting the Earth in around 6 months. And the impact probability was 1 in 2,500. And this impact was confirmed by the JPL and by the European Space Agency, Clumon system. And they were able to find some more information about this asteroid, like its absolute magnitude. And they found the absolute magnitude by looking at the magnitude that you can see from the Earth and finding how much reflectivity normal asteroids have, and then finding the magnitude, the actual magnitude of the asteroid. And they were also able to estimate a size range of the asteroid based on the observations that they took. But as they had just started observing the asteroid, the asteroid had a big range of observations, big range of sizes, from 35 to 700 meters. And where will the asteroid impact the Earth if it impacts it? So, this we couldn't really find out where exactly it will hit because we didn't even know it was going to hit the Earth, let alone where it will hit the Earth on. So, what they did is they took 7,000 random samples of where the asteroid could be, and they ran it. So they ran the algorithm 7,000 times, and each red dot that you can see on the second figure is where the asteroid will hit the Earth. So you can see it could be anywhere. Okay, so this is the information that they gave before the conference started. Now let's look at the information on the first day. So they couldn't take some observations for some time because as you would know, so basically it was a full moon. So that means that you could not really see the asteroid. So it was a couple of days before they could take some more observations. And when they took the observations, the impact probability rose from 1 in 2,500 to 1 in 20. So this was a huge difference. And yeah, so now the next step would be to, I'm sorry, so basically now the International Asteroid Warning Network basically is going to start releasing weekly updates of this asteroid and new information that people have gotten until the impact. So now, where is the impact location? So this is still really unsure of. You don't know where it was. So each purple region you can see in all three images is where the asteroid could potentially hit the Earth. And you can see that it covers basically all the place. So now, what is the next step to find more information about this asteroid? Well, the next step is because we need to get more observations of this asteroid. But this asteroid might not be a new asteroid that was just created. It might be an asteroid that's been there for like 10 years. So, and we might even have seen the asteroid in some images that we got. So what the next step could be is that sky image archives could be looked at, and they could be finding if this asteroid was in one of those images. And if you could find so many observations of these images, then you could see, you could have a better estimate of the impact probability. And now, before we go on to the next stage, we can also look at the damage that this asteroid would do to the Earth if it hit. So you can see on the first map where it has where it will affect the most population that you can see in the oceans. It won't affect that many people because and and in the second one you can see that there's a very low chance that would actually affect many people because it would probably land in an ocean because Earth is mostly water. And so you can see that it is a 97.4% chance it would basically affect no one. So now let's look at the second day. So now they were actually able to find archive images of this asteroid using the Pan-STARRS asteroid survey from 2014. So now, based on the last years of observations of this asteroid, they were able to find that this asteroid will definitely hit the Earth. There will be 100% chance of hitting the Earth. And this means that so we now know that it will definitely hit the Earth. And now what will start to change is basically where it will hit the Earth. So we'll have a better idea of where it will hit. My screen doesn't seem to be moving.
Do you want to unshare and then reshare, Arushi?
Yeah, I'll try.
Let's see if that helps.
Arushi, just real quick, you and your genius are incredibly impressive.
Thanks.
My goodness. I am watching spellbound.
Okay.
And you're back.
Okay. So now let's look at the impact location for the second day. So as you guys can see, that this it hit basically in Europe or North Africa. So we can now see that the impact place has shrunk a lot from basically most of the earth to just this area. And you might notice that there are different colors on this map. And the dark red means that it will basically the color shows what's the chance that will hit in that area out of the whole circle. So dark red it's 40%, where it's medium red it's 87%, and where it's very light red it's 99% chance that will hit in that area. So now let's look at the third day. During this day, we were able to get infrared measurements from a nearby satellite. And based on this information, we were able to get a better size estimate of the asteroid, which will help us find the damage of the asteroid later. And so basically, they narrowed the size down to 35 to 500 meters. So instead of 700, it's become 500. And the location also has shrunk a lot from the Germany, Czech Republic, Austria, Slovenia, Croatia, and this means that we were able to get a better and know where it will impact. And the colors are the same as last time. So dark red is the lowest chance, light red as it covers a bigger area is the highest chance. And now that we use such where it will impact very precisely, we were able to see the damage that would do. So basically how much population it would affect. So as you guys can see, there's not really any oceans in this area, which means it will affect a large population. So as you can see in the second map, in the probability map, you can see that it seems to be affecting at most probability 10 to the power 5 to 10 to the power 6. So around 1 million people. So this is a lot. And you can also see in the first figure that similar to the impact location, you can see where it will impact the most. So in the middle, you definitely won't be able to survive. While on the outside, it's still a very serious problem, though you can possibly still survive. Okay, so now the next day, they were able to get more information because at this point, at this point, the asteroid was very close to the Earth, and it was only 6 days away of impacting it. So this meant that we were able to look at this object using radar, so basically sending signals to this asteroid. And using this radar, we were able to get a really good size estimate of this asteroid. And we were able to find that the asteroid would be from 94 to 116 meters. So now we had a really good impact, size range of this asteroid. But as I said before, there was only 6 days until the asteroid would impact. And this meant that we would not be able to make sure that the asteroid does not impact the Earth using a kinetic impactor or moving the asteroid away by sending something towards it. And this means that in this scenario, the asteroid would definitely impact the Earth, and then we would not be able to do anything to make it not happen. And we were also able to get more impact locations, so where exactly it will impact. based on the size and more observations, and you can see that it will be right here in Czech Republic and Germany. And that means that we want to be able to find where exactly it will impact. It's now too late to stop. So either we'll have to basically evacuate that place, or in this scenario, people would die. So that makes end to basically the 5 days of scenarios of this asteroid. But as I said, there's more to this simulation. So basically, in this scenario, they developed a simulation which basically the asteroid is impacting the Earth, and you have to try to deflect it to make sure it does not impact the Earth. So I'm going to just run to you what you will see in the simulation. So first, if you look at flexion, this graph basically shows the distance the asteroid is to the Earth, and the x-axis is the time before it will impact the Earth, and the y-axis is the distance to the asteroid, the distance the asteroid will be to the Earth in astronomical units. And let's look at section 2, right here. So in section 2, we can see the orbit of the asteroid and the orbit of the Earth until the collision. And on the section 3, this is an interesting part. This basically, the light blue circle shaded that you can see signals the Earth, and the small green circle that you can see signals the asteroid. And in this scenario, the asteroid, you can see it's on the blue circle, so it will be impacting the Earth. So our aim is to basically move that green circle outside of the blue circle, and even outside that dark red circle that you can see. Because if the asteroid goes in between the blue circle and the dark red circle, then the Earth's gravitational pull will pull it towards the Earth, so it will still impact the Earth. So we have to move that green dot all the way outside this red circle. So what do we impact the asteroid with? So impacting the asteroid, we'll be doing it with different rockets. And you can see this is 3 examples of rockets that you guys would find in the simulation. And in the rockets, there's 2 things that you can see. First is the launch cost. So how much money it would take to make the rocket, first of all, and then to launch it. And the second one is the payload that it will give to the asteroid. So basically, this is how much weight it would give to the asteroid. And with more weight, you can move the asteroid farther. So now I will be showing you guys a live simulation of this asteroid. So can you guys see the simulation? Okay, great. Yeah. So the first thing that we have to do is set. So first of all, you guys can see the same 3 figures that you guys saw in the presentation. And the first thing is to set the campaign limits. So basically, what this is that you set what you want in the simulation. First is basically the 4 different vehicles that they give: the Atlas V, the Delta 1V Heavy, the Falcon Heavy, and the NASA LSS 2V. And the second here, you guys can see the cost, and this is in billions. So this shows how much cost each asteroid would show, like you guys saw in that slide. So each cost of rocket would give. And the next one is the vehicle max. So this basically, for the purpose of the simulation, is what's the maximum amount of rockets that you can send to this asteroid. And so maximum amount of Atlas, Delta, Falcon, and NASA SLS. So for now, I've said that to you. Now, when was this asteroid first spotted? So in this case, for the PDC 2021, it was 6 months. And 6 months is not, as we saw in the simulation, in the scenario, is not enough time to deflect the asteroid. So because we won't have a chance to deflect this asteroid, I've changed it from 6 months to 10 years. Next, is just the maximum amount of vehicles in whole you can launch and the maximum amount of budget in billions of dollars. So now with this, I'm going to set the limits so we can start actually doing the simulation. So first, you guys can see the direct deflection. So what this is basically when do you want the asteroid to impact the Earth? And when you want a rocket to impact the asteroid. And this is measured in days before the asteroid will hit the Earth. And you can see it is right now 1,000, but you can change it up and down based on what you want. And this is basically this yellow line that you can see here. That says D. And this means basically on the graph, you can see how far away it is to the when it will impact the Earth. And I guess look at the second one here, transfer time. So this basically shows how much time do you want the rocket to take to go to the asteroid. And this also you can choose. Next, you can also see what different types of rockets that you want to use. Atlas, all of those ones that you can see. So right now, I'm just going to go with the default Atlas.
Arushi,
Yes?
I have great respect for what you're doing here, but you have a lot of questions on YouTube.
Okay, I'll finish this quickly then.
Thank you.
So now, as you can see in the third section, the dot has moved from its original point where the red dot is to the green dot. So this means that we have successfully been able to move this asteroid, but it's still inside a red circle, meaning it's still impacting the Earth. So one thing that we can do to change that is to give a heavier rocket to impact the asteroid so it would go farther away. For example, the NASA LSS. And as you can see, the green dot has moved all the way down, which means it's not impacting it's not going to be impacting the Earth anymore. And later on, you can also change basically the performance metric. So the performance metric is basically how far away you're moving the asteroid with a total cost. And this basically, so basically what you guys can do is you guys can change the time of deflection based on what you want so that you can move it, you can make the performance metric higher while also using low cost rockets. I won't really go into details of that right now, but you guys can basically try around changing the days, changing the rockets, and seeing how much you can change the performance metric. Also, I'll just go briefly. This is a deflection map that help you find basically where you want to impact when you want the first two numbers, the days that you saw. So the x-axis is the amount of days before the impact, and the y-axis is how much time it takes. And the brighter colors are where it means it's the best time. So for example, if you wanted to have the best performance metric, you could find one of these yellow spots and you could try with those same days. Yeah, so I'll leave it at that. And if you guys want to, for example, try this simulation yourself, I'll leave the link in the chat. And you can also see it on my screen.
Bravo. Literally, bravo. That was a masterclass in synthesizing a ton of data and experience and insight into a very cohesive. Boy, Aaron, take over. I don't trust myself right now. I'm so overwhelmed with pride.
I will tell you, Arushi, and I was secretly messaging Jim behind the scenes while you were presenting. You are better at calculus. Your comprehension and application of math is just tremendous. And I feel just very, very, overwhelmed. But very able to articulate some smart questions from some smart people in the audience on YouTube. So you're open to these?
Yes.
Awesome. So one of the questions that came up is, they're actually connected. I'm going to read them both. One is, what would be your individual actions in this scenario? And what would you recommend to the general public? And then the other part is, how could you use technology to better prepare the population?
Yeah, sure. So first of all, yeah. So what I would do in this scenario. So so in this scenario, basically what we need is basically taking many observations of this asteroid. So I could also help by using some telescopes that I have access to actually image this asteroid and to basically share this image with NASA and so on, so that they can find better observations of this asteroid. And how what should a population do? Well, I guess it's also good to educate the population, which is why they're already if this happens, they're already going to be sending newsletters. So basically, about what is this asteroid and more information that they are, so the population can know what is happening. And how can you use technology? Well, I guess technology is also including sending rockets, which is basically a kinetic impact. So basically, that is really helpful for deflecting these asteroids because we do not want it to impact the Earth because that will create a huge problem. And yeah, you can use basically technology like that to deflect the asteroid.
I wonder also, I think these are great responses. Do you see an application perhaps between the need to educate the population and opportunities using technology? Like, is there a possible connection there?
Yeah, definitely. So yeah, after like educating the population, you can also show the population lots of technologies that they can use, like for example, different telescopes that they can use, and maybe even some of the general population can also take their own observations of this asteroid, or find maybe even use technology to find other ways to find these asteroids in advance and prepare for what will happen if when the asteroid comes and impacts.
I also think about, I know we live in the same province in Canada.
Yes.
Right? We're in Ontario. I can't help but think about the app that we had to download. I don't know if you had it for COVID-19 that gave you alerts, right? If you had been exposed, do you know about what I'm talking about?
I know what you're talking about, but I haven't used that app myself.
Yeah. So it was supposed to prompt you if you had been in the vicinity of somebody who had a positive diagnosis, so that you would know that you were at risk. Anyway, ideation. It's just infinite what you're doing right now, and it's so impressive. Another question from YouTube. Jim, why don't you pose this last one?
Okay, so there are two questions, and one of them is mine. The first one is, how would you advise global leaders to use this data? You're a leader. It's obvious you're a leader. What would you advise leaders to tell the people to get them to become educated about this kind of information?
Well, first of all, I would like leaders to basically share all the information about the asteroid and not like hold things back from the population or keep them only for specific people. And that would also help because the population would know what is happening and maybe even give population like resources that I said before to find and look at the asteroid and maybe even technology.
So my second question is, are you aware of the SETI program, the Search for Extraterrestrial Intelligence? SETI.
I think I heard that name before, but I'm not following it or anything.
So what they did was they created an application early that allowed the SETI program to allow independent telescopes and astronomers to give their data watching for signals. What if you were to enable independent astronomers, their data, and pull together an algorithm to watch the skies? Would that be a useful way of applying your passion for this?
Yeah, I think that would also be a really great idea because once you have lots of data, you're able to find many more things. Like for example, in the asteroid scenario, you can find more data about this asteroid. And yeah, that would be a great thing to do.
Oh, Arushi, you've just Do you follow baseball? Do you know what you understand baseball?
I don't play it.
What's your favorite sport?
Probably some water sports like swimming or biking or yeah.
Yeah, you just ran a triathlon and you were first through the gate. You swam, you biked, you ran amazingly well.
Thank you.
Brava, brava, my dear.
Thank you.
Thank you, Arushi. And I have no doubt we'll see you again soon, either on Gift or elsewhere. Keep up the fantastic work. I hope you find time to enjoy your summer and to get magic done.